Welcome to lecture 22. We are studying basic electrical engineering. Today we will talk about AC signals. An AC signal is a signal that has a magnitude and direction as opposed to uh, DC, where we have a constant magnitude. An AC signals can be of many types. They are either sinusoidal, can be a square wave, can be a triangular wave, a sawtooth wave. But for circuit analysis, for linear circuits, we most of the time use this sinusoidal wave. We call it sinusoids, because there are two types, either cause or sine. They are interconvertible, or in other words, they are shifted versions of each other. Cos of omega t and theta, sine of omega t and theta. First, we'll talk about the cos function. A cos function can be written as a function a of t is a cos omega t plus minus theta. Where a is the magnitude, omega is the frequency, t is the function, t is the time for which a of t is the function, and theta is the phase. Let's talk about what these terms are. Cos and sines are plotted in a similar way. They have the same shape, except that sine can be written as the shifted version of cos and vice versa. The magnitude means, suppose we have these three waveforms, for which if we have this magnitude V, this magnitude will be 2V, maybe this magnitude is 3V. So each sinusoidal wave can be characterized by one of these. One of the terms with which a sinusoid can be characterized is the magnitude. The other term is the frequency. Frequency means the number of cycles in a unit of time. For example, if we have this unit of time and this wave has only one cycle, this has a lower frequency compared to this. So this has a lower frequency. This has a middle frequency. And this signal has a high frequency. So frequency means the number of cycles in a unit time, mainly in 1 second most of the times. Phase. Phase. The term theta refers to phase. Phase can be thought of as the difference between the time lag or time lead between two waves. So phase can be described as the difference of time between two or more waves. Suppose we have these two waves, let's call it A of t and this as B of t. So we see that B of t starts after A of t, maybe after theta time. This theta is the phase difference between these two waves. So this is a relative term described in terms of two or more than two waves. If a term with respect to phase, we define two more terms for AC signal analysis, either lagging or leading. A signal A of t and B of t can be, a signal B of t can be thought of as lagging A of t. It starts after some times theta. So we say B of t lags A of t by theta degrees. Or in other words, we can write A of t leads B of t by same theta degrees. These phase terms can also be, the sinusoidal signals can also be represented if suppose for A of t and B of t we have the same magnitude term k cos omega t plus theta. B of t has also the same magnitude term, the same cos, the same frequency plus theta minus 90 degrees. How do you plot these two together? This is like this. A of t, B of t is this. This minus represents lagging behavior. So this means B of t lags A of t by 90 degrees. The magnitude is the same, the frequency is the same. So it should start after 90 degrees. So B of t is k cos omega t plus theta minus 90. This means it starts after 90 degrees compared to A. Right? For these signals for which we have the same magnitude and same frequency, we can write them in the form of phasors. Let's see what a phasor is. A phasor is a vector representation for which we have a magnitude term and a phase term, and we use it for sinusoids when two sinusoids have same magnitude and same frequency. So A of t in phasor term can be written as the magnitude k at the angle of theta. P of t, the magnitude k by theta minus 90 degrees. So yeah, these two terms have same magnitude, but they can have different magnitudes, but their theta are described in terms of each other. This is theta, it is theta minus 90. This means B of t lags A of t by 90 degrees. So these phasor terms can be used to represent two quantities where we have different magnitudes, we can have different magnitudes, but thetas, the angles are described in terms of each other. Right? Let's say first the difference between cos and sine. Cos versus sine. Let's plot cos of t first. This is cos with some omega, if the magnitude is 1, so we don't write anything here, plus 0. It is going to start from 0 degrees, so there is no phase lag, and it has some frequency omega. So we write cos omega t. Let's plot a sine here. This is sine omega t, starting from 0, has some frequency omega, the max magnitude is 1. So we write it sine omega t. Right. Let's see what's the difference between the two. Let's call it A of t and this as B of t. So K of t can be written as, in terms of phasors, it can be written as a magnitude 1 with no phase lag. This means 0. Cos omega t is 0. But for P of t, the function is not cos, it's sine. So how can this sine be obtained? By using this cos. If we shift this signal, if we shift this signal cos of t, for purpose if we draw it behind 0, we see it can become a sine if we shift this signal by 90 degrees towards right. If this black signal is pushed towards right by 90 degrees, this is minus 90. If it is pushed towards right by 90 degrees, it will become exactly the sine. So this means it's a rightwards shifted version. Any version that is shifted rightwards is lagging. So lagging signals have minus angles, negative angles. So we just one at an angle of minus 90 degrees. So now they both are represented in terms of cos, one at an angle of 0 3, since this is a sine, and we have to represent all quantities, all phasor quantities in terms of cos. Therefore, we represent it in terms of cos, and the cos becomes sine if we shift it by 90 degrees towards right. So any signal shifted towards right is lagging and is represented by a minus angle, a negative angle. And any signal shifted towards left is the leading signal and is represented by an angle plus. So in the upcoming lectures, we will solve different AC circuits using AC sinusoidal inputs and circuit elements like resistors, capacitors and inductors. Thank you.